Good morning, student. We are going to talk about linear function and the slope. The graph of a linear function is a line. So take a minute and try to identify which one of these graphs or functions represent a linear function. So if you chose graph number 1 and number 5, you are correct. Those are the only graphs that represent lines and that are representative of linear functions. Um, the other graphs represent different type of functions, but none of them are linear, right? Quadratic, graph number 2, quadratic function, cubic function, absolute value function, number 6, okay? And quartic, number 4. Those are functions that you are going to study later, but right now our focus are linear functions, and the graph of linear function again are lines. Okay. Now, I want us to focus in this lesson on two characteristics of linear functions. That is the slope, that's known as the steepness. Okay. So when we talk about slope, think about a line steepness, right? And we are going to be talking also about the y-intercept. That is where the line is crossing the y-axis. So slope and y-intercept would be our focus. Okay. Most problems that deal with linear function uh, turn require you to have a good understanding of slope and y-intercept. Now, let's compare the steepness or slope of a few lines. Here they are. Now, without any measurement instrument, it's really harder to tell exactly what the slope of each one of these lines are, except for these two. Those are the special cases. This one is a horizontal line. The slope of the horizontal line, as demonstrated in class, is 0, right? Remember that when I took the flat surface, horizontal surface, and I put the pen on it, the pen was not rolling. Okay, that's demonstrated that there was no steepness or slope equals 0. Now, vertical line, the slope is undefined. Okay, the slope of vertical line is undefined. That means that the slope does not exist, right? So be careful. Undefined and slope of 0 are not the same thing. Okay, when we demonstrated for vertical line, in a vertical position, I couldn't put the pencil down on the surface, all right? But for horizontal line, I was able to put the pencil down. It was just not rolling, okay? Now, since these two are exceptional cases, let me go ahead and give you the equations, right? Now, in general, the equation of the line can be written in slope-intercept form, which is a form that is y equal m, where m is the slope, times x plus b, and b represent the y-intercept. But because the slope or horizontal line is 0, since the slope is 0, 0 times x is 0, that means any horizontal line will not have this part right here in its equation. The slope of the equation of the horizontal line will just be y equal b. Since m equals 0, 0 times x is 0, so what is left is just the b. So that's the form of an equation of a horizontal line, right? Any other line beside horizontal line, okay, can be written in slope intercept form if it's a linear function. Now, vertical line is not a function, right? Vertical line does not represent a function. As a matter of fact, um, it does not have a slope, and we cannot write it as y equal anything. Um, the equation of a vertical line, okay, would be of this form: x equal a number. All right, that number a represent the x-intercept, meaning where that line is crossing the x-axis. Okay, b is the y-intercept, by the way. Now we are going to talk about this later, right? But since we cannot tell exactly what the slope of any of these lines are, but we can still compare them based on the just the way that we can see the steepness. We can see that the slope of this line, okay, would be greater than the slope of this line, for example. Meaning that if was a hill, trying to climb this is harder than trying to climb this one, right? Because this one is steeper, right? So the slope of this one is greater than the slope of this one, right? Now, let's find a more precise way to compute the slope of the line. Before we move on though, just notice the direction of the line. If a line from left to right is rising, okay, its slope would be positive, okay. We write greater than 0 to say positive. But if a line is from left to right, if you are going down, falling, okay, the slope would be a negative number, right? Uh, so the negative and the positive just tell you the direction, but in terms of the steepness, um, the value absolute the steep of uh, uh, of that number will tell you exactly how steep that line is, right? So let's move on. A more precise way to compare slope is to know the value. Now, if you are fortunate and they give you the graph and you have the way to measure the vertical change and the horizontal change, um, you can find the slope that way. Let's assume, okay, let me change color. Let's assume that you are moving from this point right here to this point right here. Remember, while you are moving from here to here, there's a vertical change. And that vertical change in this case, if we move from this point right here to this point right here, is going to be 1, 2, 3 unit. So vertical change 3 unit. How about the horizontal change? Okay, because if you're moving from here to here, you're also uh, changing horizontally, and that horizontal distance would be 1, 2, right? In this case, right? Guess what? This is exactly what the slope of that line is, 3 over 2, all right? So how did we find it? We found it by finding how much the horizontal change, the vertical change is between uh, the 2 point, this one and this one, and we found that was 3, and how much the horizontal change is between these 2 points, and that's is 2, right? So the slope of a line is the change, vertical change over the horizontal change. To help you, I guess you are going to hear also say that slope which is we use the letter M to represent slope. I hope you see that by now. Is sometimes referred to that we find it by doing rise, okay, which is a change vertically over 1, which means a change in the x direction or horizontal change, right? And that's what we just did. As a matter of fact, um, there is a formula for it, and I'm going to go ahead and give you that formula right away. Notice this vertical change of 3. We can find it by just subtracting the y values. So, for example, if you do 1 minus negative 2, okay, 1 minus negative 2. So I'm subtracting here the y values of these 2 points right here, okay, over, okay. Now I'm going to subtract the x value of those, the 2 point, negative 3. Sorry, what aren't you writing? Negative 3 minus negative 5. So if we subtract, okay, the y values, that will give us this distance right here of 3. So 1 minus negative 2 is 1 plus 2, and 1 plus 2, and 1 plus 2, that's equal to 3, right? And in the denominator, negative 3 minus negative 5 is the same as negative 3 plus 5, okay? So 1 plus 2 is 3, and negative 3 plus 5 is 2. So you see, we get the same answer as before, all right? But how did we do that? All right, we just use this formula right here, in black maybe. That slope is, okay, the difference between the y values of 2 points, we say y2 minus y1, over the change in the x value that we summarize by x2 minus x1. Here it is. So that's the formula that I applied. Okay. Write this down somewhere. You are going to use it a bunch of time. So, and you can see, so if you can basically measure, okay, the change in the y direction, just write it down and divide by the change in the x direction, and that would be your slope. If they just give you the value, the coordinate of the 2 points, you can basically use this formula to find your answer. Now, let's explore this line on my right hand side right here. Okay. Now we are again talking about an horizontal line and a vertical line. All right. So we already mentioned that the slope of a horizontal line is 0. But how do we know that? All right. So look at, if we consider this point right here, this point right here, okay, and this point right here, wrote the coordinate right here. So if I were to move from this point to this point, how much am I changing vertically? No, there's no vertical change. I did not move up anyway. So the vertical change is 0, right? But how much did I change horizontally? Let's count. 1, 2, 3, 4, 5. Okay. So the slope would be 0 over 5. 0 over any number is 0, right? So this confirms again why the slope of a and horizontal line is 0. Because there's no vertical change, that means when we want to write it, we are going to always have 0 right here for the vertical change, and 0 divided by any number is 0. Right? Of course, try to use the formula, okay, this formula right here, to show that and these 2 points right here to show that the slope of an horizontal line is 0. Go ahead and do that. Right? We are going to practice more of it in class, but I want to keep the video short. So here is a vertical line, right? We say the slope of a vertical line is undefined. Why? Okay, let's consider this situation. If I were to move from this point right here to this point right here, okay, how much am I changing vertically? So if you count 1, 2, 3, 4, 5, 6, 7, 8, so that's 8. Now, how much am I changing horizontally? I'm not changing horizontally, so I put 0 there. Okay. Now, we all know that in math, we cannot divide by 0. Therefore, this division by 0 cannot be performed. So we said that the slope is undefined. You can hear also that the slope of a vertical line is infinite. That's the same meaning as being undefined. Okay, let's move forward. Okay. Now, one thing that I want you to make sure of that you understand is that what makes the slope of a line a linear function special is that it's a constant. Okay, meaning that any 2 points that I'm going to take on a line, okay, the slope would always be the same. For example, right, this line right here, if I want to find the slope, right, first, because from left to right I'm going down, that means the slope would be negative. But let's find it, right? I need to change this to something I can write with. Okay, so let's take this point right here and this point right here. So the vertical change will go down by 1, and we have to go over by 1 also horizontally to hit back the line. So that means going down by 1, that our vertical change is -1 and our horizontal change is +1. So that means the slope is a -1 over 1, which is just -1. Okay, let's take 2 more points of this line and see if we are going to get the same answer. Okay, this point right here. So how much do I have to go before down and go over before I hit the point again? So I'm going to line again. So I'm going to go down by 1, 2, 3. So that's -3. Okay, -3. Okay, and I'm going to go over by 1, 2, +2. Huh? Hold on. 1, 2, 3. Oh, I miscounted it. Negative, +3. Okay, so the slope will be -3 over +3, which is the same as -1. Okay, please count it properly and don't make the mistake that I just did. All right, the slope of the line is always the same. Now, this line is rising from left to right. Guess what? The slope would be positive. So, from this point to this point right here, we are going, okay, if I go up by 1, 2, I have to go 1, 2, 3, 4, 5 to hit the graph again. 1, 2, 1, 2, 3, 4, and 5 to hit the graph again. So we are going to say the slope of this would be rise, which is 2 over 1. That's the horizontal distance, 5. Right. Of course, you can find the coordinate of this point right here and use the formula to find the slope of these lines. Okay. Just for you to get used to algebraically find the slope of lines. Just remember, the slope of a line is constant. That means it's the same between any 2 points on the line. Again, here is the formula to find algebraically the slope of the line. Now, I think I already covered how to find the slope of the line. So this is like a recap. Okay. To find the slope of the line between any 2 points on the line, just take the vertical distance, the change, and between the 2 points, divide by the horizontal distance. Okay. This is known also as change in y, meaning vertical change, over change in x, horizontal change. Okay. So if you take any 2 points on the line, x1, y1, meaning first point, and x2, y2, second point, then you can use this formula right here to find the slope. So you subtract the y between each other, divide by the difference between the x's, right? Just make sure you keep the order, meaning that if I'm doing the second point, y2 minus y1, okay, I have to just start also at the bottom by x2 minus x1. You don't flip the order. Okay. So we just demonstrated how we can use the graph, okay, or of a line to find the slope. Okay. If you are given the point again, use the formula. Now, what if they give you the equation of a line in slope-intercept form? This form right here is called slope-intercept form because M is your slope, okay, and B is the y-intercept, right? Now, if they give it to you in this format, the value that is multiplying your x is your slope, right? For example, if they tell you that what is the slope of a line which equation is y equal 5 over 2x plus 7, so the slope of that line would be m equal 5 over 2, okay? The 7 just means that's where it will be crossing the y-axis. We call that the y-intercept or b, right? Now, what if the slope, the equation, they give you an equation that is written in standard form, okay? This format right here is called standard form. So, if it's written in standard form, then you find the slope by dividing the opposite of a over b. For example, if they give you in standard form 4x plus 3y equal 5, so your slope, the slope of this line, would equal to uh, -4 minus a over b, and b is uh, 3. Remember, this A and B has this B has nothing to do with this small b right here. This b is not your y-intercept. As a matter of fact, to find the smallest b, your y-intercept, you do c, whatever the value of c is, divided by the big B right here. Okay. The most popular form, though, is the slope-intercept form. Okay. The next popular one is the standard form, right? Slope-intercept form, that's one that should be the first one that you get to know very well, right? Okay. Now, note all linear equations. Okay. All linear, uh, shouldn't say equations, or I guess functions, right? If you are a function, a linear function, okay, your equation can be written in slope-intercept form or standard form. So if you take an equation and you cannot write it in either slope-intercept form or standard form, then that equation is not does not represent an equation of a line, right? So that's one way to tell if an equation is of a line or not, right? If you cannot write it, you cannot reorganize it in slope-intercept form or in standard form, then that equation does not represent an equation of a line. Okay, so we already talk about those two special cases. Okay, equation of an horizontal line is of the form y equal b. Okay, and b is basically where the line is crossing the y-axis. It's called the y-intercept. Since the slope is 0, you don't have the part that we say m times x here, right? Any horizontal line. So anytime that you see an equation of a line that is equal to y equals some number, okay, let's say 5, okay, then this line will be an horizontal line that pass through y equal 5, right? The slope is 0. Okay. So the equation of a vertical line is x equal, right? Remember, vertical line is not a function, right? X equal a. A in this case represent the x-intercept. That means where the vertical line is crossing the x-axis. So that's what that a is. So x equal a would be the equation of a vertical line, right? And again, a vertical line is not a function, right? So now, term used to refer to slope in real life. This is important because it will help you solve word problems, right? Um, the word slope and rate, rate of change, hourly rate, speed, unit rate, unit price, okay? And look for keyword related to rates such as per, each, and every, okay? All those words uh, tells you that, hey, they are talking about slope right here, okay? That will help you identify the slope in a given problem. And okay, uh, term that are used to refer to the y-intercept in real life or word problem is initial value at the beginning, from the start, base salary, and word that are related to the meaning of the starting point, starting value, stuff like that. So all those uh, words refer to the y-intercept. Okay, why is that important? That you are able to identify your slope and your y-intercept. This is important because for you to write an equation of the line, you basically need your slope and your y-intercept. That's all you need, right? Because those are the only value that you are going to be replacing. Y and x stays as a variable in the equation. The only value that you are looking to replace is the slope m and b, right? For example, if I read the problem, um, and in that problem, so I was able to identify that uh, the slope, the slope is 8, right? And I know that the y-intercept, for example, uh, is, let's say 20. I can just go ahead and write the equation by saying that equation corresponding to this information will be y equal 8x plus 20, right? So the only two things I need to worry about replacing in the formula is the slope and the y-intercept. That's why it's so important that you remember you are able to identify the slope and the y-intercept, right? If they ask you to write an equation of the line, go for the y-intercept, right? If they give you an option to choose what you want, y-intercept is the easiest way. Now, when we talk about the variable x and y, just understand that depending on the context of the problem, we can use the other variables, right? For example, if you are talking about a situation where it's about a pay, they are paying you to do some work and you have your hourly rate, uh, right? Uh-oh, click on the wrong thing. Sorry. If they are paying you, okay. If they are paying you, okay, and $8 an hour, and let's say that they are giving you $20 as a starting every time that you as a base salary, and every hour that you work, remember I use the word every hour, they are paying you $8. So I identify my slope as 8, and the base salary, the starting salary is 20. So that's 8 times t plus 20. That's the form mx plus b, right? If you are traveling, all right, um, they say you are traveling 30 miles per hour. The 30 miles per hour, the 30 is your slope, right? The keyword per hour, right? That's the rate of change, right? And you already did 80 miles, right, in your trip. So you are starting off with 80 miles already traveled. Now they are saying that the rest of the distance you are going 30 miles per hour. So you identify your slope, okay? Your x is now t based on this context, and I can. So I hope you get the point. Okay, I'll stop here. This was just a brief introductory, and we are going to go through specific uh, exercises in class to reinforce this concept. Take care, and I see you in class.